Hi guys, we need to know some things before we start chapter 5, which is on similarity and proportions. So this video is going to highlight 4 main ideas. So I'm just going to get started right away with just some fractions, all right? So the first concept is going to be simple proportions. So in order to think about what simple proportions are, we need to go back to, earlier school, elementary school, middle school. But I want to write some equivalent fractions for the samples below, right? So 2/3 is our first example. So we could do things, like, hey, multiply both the numerator and the denominator by 5. If we do that, we get an equivalent fraction. As long as we're doing the same thing to the top and the bottom, 2/3 is equivalent to 10/15, right? And we could do that really with any numbers. We could multiply by, -11, right? And in each case, we would get -22 and -33. Now, why is it equivalent? Well, because, first of all, we multiplied by the same, I'd say scale factor, or multiply by the same number, but this fraction would reduce back to 2/3. Okay, similarly, if the fraction is negative, then our equivalent fraction would also be negative, right? But here's something that you're going to notice in the next few examples. You're going to take that negative and you're either going to put it in the numerator or denominator. Okay, so in this case, I'm going to choose to put the negative up top in the numerator. Okay, and then if we want to create equivalent fractions, then we could just multiply by, a common number. So I'm just going to multiply by, say, 4. Just picking numbers randomly. So one equivalent fraction to -7/5 would be what? -28/20. Okay, so that would be equivalent to -7/5. Okay, so just as a reminder, guys, you should be writing down each of these things as we're going through. Alrighty, so what we're going to do is we're going to next talk about something called the cross product. The cross product you've seen before, right? You might have also called it cross multiplying. There's something pretty cool and helpful that happens when we try to cross multiply. So first of all, I'm just going to cross multiply with these values here. 4 times 9, I'm going this direction, right? 4 times 9 is going to give me 36. 12 times 3 is also going to give me 36. Now this is important. When the cross product is equal, then that means the fractions are equivalent. So for example, if I just go back here real quick and reduce 9/12, what could I divide both 9 and 12 by? Well, yeah, I could divide them both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4, and that is equivalent to 3/4. So long story short, if we cross multiply and get the same number, then that means the fractions are the same. The fractions are equivalent. Let's try the other couple examples here. All right, so for example, and remember before, I'm going to take my negative and put it either in the numerator or denominator. Okay, so in this case, I'm going to put it in either the numerator or denominator. So let's give it a shot here, right? So I have -6 times 8, which is -48. And then I have, look at that, -3 times 16, which is also -48. What does that tell us about these fractions? Well, it tells us that the fractions in the beginning were in fact equal or equivalent. All right, what I want you guys to do is try that cross product here and tell if these fractions are equivalent. Well, if we do that, we get 2 times 11 is 22. 3 times 9 is 27. Therefore, these two fractions are not equivalent. I'm going to put the not equal sign in between. Okay? All right. And similarly over here, are these two fractions equivalent? Well, let's see. 9 times 12. Let's see. That's going to be 9 times 10 is 90. 9 times 2 is 18. So that's going to give me 108. Okay. Let's see. 8 times 13. What's that? 8 times 10 is 80. 8 times 3 is 24. That's going to give me 104. Therefore, these two fractions are not equivalent. Okay, now we're going to take the idea from above and try to use cross-multiplying for what we really need it for, to solve an equation. So first of all, you'll notice that they're telling us that these two fractions are equal. However, there's a missing number. So our job is to find what is that missing number that would make these two fractions the same. Now, although I know you guys can probably do some of these in your head, they're gonna get a little tougher. They're gonna have more steps. So what we wanna do is build good practice right off the bat. So what we're gonna do here is we're gonna notice that, hey, we have one fraction set equal to another fraction. That's called a proportion, okay? How do we solve proportions? We're gonna cross multiply. So here we go. So what I'm gonna do first is I'm gonna multiply 17 times x. Now guys, before you saw us writing 17x over here. I'm gonna start to use an equation. So 17 times x, I'm gonna write that here as 17x. I'm gonna carry down my equal sign, and now I'm gonna set that equal to the other cross product. Now 2 times 34 is gonna give us 68. Guys, really importantly, when you're done cross multiplying, the fractions are gone. And now we have a nice simple one-step equation. How do we get x alone? Well, this is 17 times x, so we're going to divide both sides by 17, giving us x equals 4. Okay, let's head over to the next example. Same idea. We have a proportion. Why is this a proportion? Because it's one fraction set equal to another. Okay, but I'm going to cross multiply. 2 times x is 2x. I'm going to carry down my equal sign. Okay, 3 times 28, let's see, 3 times 20 is 60. 3 times 18 is 24. Together, that's going to give me 84. Okay, or use your calculator, it's totally fine. Guys, we have no more fraction left. We just cross-multiplied, no more fraction left, but we have a nice simple one-step equation. So I'm going to divide both sides by 2 and get x equals, what's half of 84, guys? Good, 42. Alrighty, so what I'd like you to do is, let's head down to part C here, and I want you guys to solve this proportion. However, remember, we're going to take our negative and either put it up top or down below, right? In this case, I'm going to put it in my numerator, so here's what I'd like you guys to do. Please solve by cross-multiplying. Okay, if you cross-multiply, we get negative 2x equals 54. Now we're going to divide both sides by negative 2, and that's going to give us our solution, which is x equals negative 27. Now I want to do something here that we haven't done yet. I want to check my solution. I think that's really important, okay? Check your answers when you're finished. So I'm going to go back to the original expression, the original equation, and I'm going to take my negative 27 and put it there. There's two ways to check this. I have 6 over negative 27, and remember we put the negative up top, negative 2 over 9. So one way to check this would be by cross-multiplying, right? And we should get the same number. However, there's another way to check this. This is negative 2/9 simplified. What can we divide into 6 and negative 27? Well, that would be 3. And guess what? 6 divided by 3 is 2. Negative 27 divided by 3 is negative 9, which equals our other fraction. All right, so guys, let's take everything we've done in these three examples. I'd like you to please solve this proportion. Okay, I'm going to put my negative up top and cross multiply here. That's going to give me 3x, drop your equal sign down, equals negative 2 times 48. That's going to be negative 96. Now remember, after we cross multiply, no more fractions, okay? Now we're going to simply solve to find x. In this case, x is going to be negative 32. All right, the second part of this video takes, kind of just takes right after what we just talked about. So if you notice here, guys, now we're solving linear proportions. All that means is these kind of look like y equals mx plus b. Notice the mx plus b. Listen, it really is the same exact things. We have a proportion. Why is this a proportion? Well, because it's one fraction set equal to another. Okay, so how do we solve proportions? We're going to solve proportions by cross multiplying. Now, there's a couple extra steps in these examples. So we're going to do part A together, and then I'm going to ask you guys to try part B below. So first and foremost, we solve proportions by cross multiplying, but I need you guys to get in good habits now. I'm going to take x plus 1 times 6, but here's how we're going to write it. I'm going to write it as 6 times x plus 1. Now, the reason why I'm doing this is to remind me that it's 6 times both things. It's going to remind me to distribute. All right? The same thing happens on the other side. I have to do 5 times x plus 9. So I'm going to write that just like that to remind me to distribute on both sides. Okay? Now that's going to give me 6x plus 6 equals 5x plus, what's 5 times 9 is 45. Okay? Now guys, remember, after we cross multiply, there's no more fractions. Okay? And now we're just going to solve and balance this equation. So I'm going to choose, and you could start with a couple different things here, but I'm going to start off by subtracting 6 to both sides and carry down my work. That's going to leave me 6x equals, make sure guys, the equations stay equations, drop that equal sign down. And now I have 5x plus, what's that, 39, right? 45 minus 6. Okay, and now we're almost done here. I'm going to have to get my x's to one side, so I'm going to subtract my 5x. And I'm pretty happy here because I'm done because 6x minus 5x is just plain old 1x. Okay, so I believe my answer is x equals 39. Now, how do we check our work? We're going to take our solution, 39, and plug it back into both of these and see if it works. Okay, so let's see. 39 plus 1 gives me 5 over 40. And 39 plus 9 gives me, what's that, 48? Right? And now what we want to do is we want to test and see if these two fractions are equivalent. Okay, so if you want, you can simplify each of the fractions. That would work, right? 5/40ths would simplify to, let's see, divide by 5 would be 1/8. Over here, same thing, divide by 6, which gives us 1/8. Or you could cross multiply. Let's go back a step. Or you could cross multiply 6 times 40 and 5 times 48. And guess what? You would get 240 for both. That would tell you they're equivalent. Okay? So let's go down here to the bottom here. X equals 39. That's our solution. Okay, and here we go. We're going to start by cross multiplying. You guys are going to finish this up. But we're going to write 7 times x plus 3 equals, make sure you bring down equal sign, 2 times x plus 7. All right, guys, please go ahead and finish this up. Let me know what you get for x. All right, let's see what happens. So that's going to be 7x plus 21. Don't forget to distribute. Equals 2x plus 14. All right, now I'm going to speed this up a little bit. I am going to subtract 21 to the left, leaving me 14 minus 21 is negative 7. And I'm going to subtract 2x over, leaving me 5x. Now, guys, listen. We end up getting negative 7/5. Okay, which is, it is the same thing as getting the decimal negative 1.4. Okay, but I'm going to leave my answer as negative 7/5. Fractions and decimals happen. Fractions and decimals happen. So if you're not sure, you take your number. All right, if you want to take negative 1.4 and plug it back in, you can tell yourself that you are in fact correct. All right, the third idea in this video is going to take your proportions to the next level. It's going to talk about similar figures, okay? Similar figures are not the same figures. If they were the same, we would say they're congruent. But since they're not exactly identical, we're going to call them similar if they have 3 characteristics. So right here, take a listen with me, right? Similar figures are not congruent. They're not identical. They're not the same. But they have 3 characteristics. Here we go. All figures are similar. If they have the same shape, equal angles, and proportional sides. Okay, we'll talk about that in a sec. All right, but if they don't have these all three of these things going on, then they are not similar. So let's take a look at this picture here. All right, and basically they're telling us here, we have one pair of equal angles, two pair of equal angles, three pair of equal angles. So first and foremost, are these two triangles the same shape? Yes, they're triangles. Do they have all equal angles? Yes, they do. But now here's the question. Do they have proportional sides? So here's what I'm going to say. 3 matches 9. 5 matches or corresponds with 15. So 4 matches with, we don't know. But here's what we're going to do. We're going to check and see what the proportion is, or are they proportional? So I'm going to compare 3 with 9. Okay? I want to see if that is equal to 5 compared to 15. And notice I'm going from small to big. Okay? So is 3 over 9 the same proportion as 5 over 15? I don't know. Let's check it out. 3 times 15 is 45. 9 times 5 is 45. Nice. So they are proportional. So here's what we're going to do. We are going to say, all right, 3 and 9 are in the same proportion as 5 is to 15. So we want to find the missing side length. You're going to choose either 3 to 9 or 5 to 15. Doesn't matter. I'm going to use 3 to 9. Now I want you to listen to how I say this. 3 is to 9 as 4 is to we don't know. Okay, so I'm going to say, watch, 3 is to 9 as 4 is to we don't know. And now we just simply solve a proportion. Now, guys, I realize you could do this without using a proportion, but again, we want to build good habits. So here we go. I'm going to get 3x equals 36. And after dividing both sides by 3, we get x equals 12. And that will be our missing side. Okay, so let's try this example right here. It says triangle LMN is similar, not congruent to, so they're not identical, but they're telling us right off the bat that they're similar. What makes them similar? Well, they have the same shape, they have the same angle measures, and they have proportional sides. So here we go. What I'm going to say here is 9 is to 41.4 the same way 7 should be to x. But we don't know x, so we're going to write and solve a proportion. So here we go. I'm going to say 9 is to 41.4 as 7 is to x. Now you're going to need a calculator for this, guys. And if you notice, we are going to round our answers to the nearest tenth if necessary. Okay, here we go. We're going to cross multiply. So 9 times x is 9x. And now I'm going to have to do 7 times 41.4. Okay, and that's 289.8. Okay, and we're going to solve by dividing both sides by 9. And that's going to give us 32.2. Now, guys, I did not have to round that on my calculator. That's exactly what it is. Alrighty? Now, let's go down to the bottom here. Oh, and last thing I just wanted to say was this. If you started from the beginning here, notice that we're going from small to large, right? So our answer needs to make sense here. 9 is getting bigger and becoming 41.4. 7 should get bigger, and it became 32.2. Okay? So what I'd like you to do here is please write and solve a proportion to find the length of our missing side, round to the nearest tenth if necessary. Okay, so let's see how we did here, but basically I noticed that 29 is in the same spot as x, right? Because FG is in the same spot as, as JK over here. Alrighty, so real quick, I set my proportion up as 29 is to x. Right, there it is, 29 is to x. Now notice I'm going the same direction as 41 is to 20. Now guys, notice we're going from big to small. So I think this number should be smaller than 29. okay? So if you notice, there's my proportion down below, and I get a number that is smaller than 29. I get 14 and an infinite decimal, so we got to round to the nearest tenths. So I'm going to say this is, ready? Do I leave it as 14.1? Yes, because the next number is smaller than 5. So I'm going to get 14.1. All right, part 4 and the last part of our video is going to review something that you've done in Algebra 1. We should be able to factor quadratics. We're going to basically be factoring and eventually solving later this chapter. So we got to remember what quadratics look like. Basically, quadratics have an x squared in it, right? That's your highest exponent. So if that's what we are looking at here, we're going to often see something x squared, right? I'll just kind of give you a little foreshadowing. See, there's the x squared. Okay, then we're going to also see something x and plus a number. So all of the examples down below follow that same format, right? See all the x squareds, something x, and plus or minus a number, okay? So let's go take a look up here. Let's try to review where we left off, last year or a couple of years ago. So the first thing I'm going to do is look right here at what is factored form. So it's a little backwards from what we're going to do in a minute, but I know you guys have done this in the past. We've used FOIL or double distributive property. I usually like to say distribute, so here we go. We're going to do x times x, which is x squared, plus 6x. I'm just multiplying here. Then I'm going to distribute the 4. 4 times x is 4x, and 4 times 6 is 24. However, we get nice common like terms in the middle. 6x plus 4x is going to give me 10x. Now, I want you to notice something here. I'm going to head over here and simplify. But I'm going to write x squared plus 10x plus 24. What I want us to notice here is I really want us to use shortcuts, okay? So basically, the number in the middle is the sum. The word sum means add, is the sum of the two numbers, okay? So if you add those, that's always going to give you your middle number, okay? And guess what? The last one, the 24, comes from 4 times 6. So I'm going to write product here. So the 24 comes from 4 times 6. Okay, let's see if you can predict what's going to happen here. What is negative 8 plus 3? Well, that's going to give me negative 5. What's negative 8 times 3? That's negative 24, but let's see what happens. Ready? So I'm going to once again distribute and do all 4 multiplications. So that's x squared plus 3x minus 8x minus 24. Be careful of your signs. But here, again, guys, look, where do we get our middle term from? We said negative 5x a minute ago. Well, that's from 3x plus negative 8. So the middle term of our answer is going to come from the sum of the two numbers, right? Negative 8, and 3. Let me clean this up a little bit. All right, and then where does the last number come from? Where did negative 24 come from? Well, that came from multiplying the two numbers. So that is going from factored form to standard form. This is where it's all multiplied out. Okay, so what we want to do below is we want to try to go backwards. Okay, so here's what we're going to do. I'm going to set up my parentheses. Okay, and I'm going to look at this example and I'm going to say to myself, hey, I need two numbers that have a sum of 11, but a product of 24. Now, here's how I'm going to do this. I'm going to concentrate, and this is what we should do, concentrate on the 24. I'm just going to do like a little bubble here, right? What multiplies to give me 24? Well, that's 1 times 24, 2 times 12, and 3 times 8. Is there anything else? Oh, yeah, what about 4 times 6, right? So ready? These are the numbers that multiply to give me 24. Which of these numbers adds to give me 11? Well, that's going to be 3 and 8, right? So what we're going to do here is this. Ready? I'm going to go head over to my factors, and I'm going to write x plus 3 and x plus 8. How come? 3 times 8 is 24, and 3 plus 8 is 11. Okay? So let's try one more of these together. Now, the next one is going to involve some positives and negatives. Okay? So the first thing I'm going to do is remind myself that this is where you need to add to get negative 15, but multiply to get 50. Okay, so I'm going to list all of the options for 50, and we'll see if we can pick one out. So I have 1 times 50, 2 times 25, 3 and 4 don't work, 5 does, right? 5 and 10. Let's see, 6, 7, 8, 9, that's it. So these are our 3 options. Now, be careful. The product, guys, look, the product is positive, but the sum is negative. So think about that. That means we have to have both negatives. All right, think about it. Negative times a negative is positive, but negative plus a negative stays negative. All right, guys, what do you think? Which numbers multiply to give me 50, positive 50, and add to give me negative 15? All right, well, that's going to be x minus 5 and x minus 10. All right, so here we go. I'm going to set this up with you, but I want you to finish it up for me. Okay, so first of all, we know that the front two have to be x times x to give you x squared. Okay, now let's look at your signs. Always do signs next. Guys, we have to have a product of negative 20. So just tell me about your signs. Well, yeah, we have to have a positive and a negative to multiply to give me negative. All right, now ready? We need to add to get negative 8, but multiply to give you 20. So let's see. That's 1 and 20, 2 and 10, 4 and 5. We got to get a negative 8. Oh, but wait a minute. What do you think here? What would work? Well, I think we're going to have plus 2 and minus 10. Let's test that. What's positive 2 times negative 10? That's negative 20. And what is positive 2 plus negative 10? That's negative 8. So we're good. All right, so guys, last thing, please try to go factor the bottom expression. What do you think we get? Well, I know that I need x times x in the front. Now, wait a minute. We're multiplying to get a positive, but adding to get a negative. So they both have to be negative. All right, and that's going to be 10 and 1, because negative 10 times negative 1 is positive 10, and negative 10 plus negative 1 is negative 11.